equivalent resistance between the A and B terminal. Actually this portion I have taken for simplifying this question. This is kind of tool. Whenever we get such a circuit across which we have to find out the equivalent resistance, we can use we can imagine a voltage source across it and a current flowing through that voltage source. When we are going to divide this voltage source by this current, that means the R AB, the voltage across V AB, the voltage across A and B terminal divided by the current flowing through this, we will get the equivalent resistance RAB, which we have to find out here. It's kind of tool, it's a technique. Okay, this was not given actually. We have taken it for simplifying this question. So now if we analyze, then we will find out one thing, that from this terminal, this is coming, the current I is coming to this terminal, this is connected to A, and from this A terminal the current gets divided into three parts. Okay, now are this current going to divide equally or not? That we have to see. And how can we see that? We have to check the symmetry. Now there are three paths for the current. If we can consider this first path, we will find out one thing, that firstly it will go through this R resistance, then there is one R, both are connected like this, and likewise if we see here also there is one R resistance, thereafter there are two R's here. Likewise here R, then two R's, it gets divided, then there is R. So and if we check this path also, one is R, thereafter there is one R, there is one R, and if we take this path, this will also get into divided into in these two parts. All the resistance are same, so every path is subjected to same resistance. Are you getting my point? Every path is getting divided, every path is getting same resistance. One resistance is come, here gets divided, here gets divided. It's through this resistance, it's here gets divided, here gets divided, and from here through one resistance, then it gets here divided and here divided. So you can see at this point the each path has the same resistance. This is kind of symmetry. So the current flowing, so the current will be equally divided into three paths. In three paths the current will be equal. And how? They will be equally divided in three paths. So current flowing through this path will be I by 3, current flowing through this path will be I by 3, current flowing through this path will be I by 3. Here through this resistance I by 3, here through this resistance I by 3, through this resistance I by 3, it will go here through this resistance I by 3, through this resistance I by 3. Now this I by 3 comes here up to this position. After that we can see it gets divided into two resistance, and this after this resistance it will go here. From this point also the current is subjected to equal resistance in both paths. So that I by 3, which current was here I by 3, that gets divided into two parts equally. So the current flowing through this will be I by 6, and the current flowing through this will be I by 6. Let me use another color so it will be easier to identify. I by 6, through here also I by 6, here it was coming like I by 3, here I by 3, through this I by 3, and through this I by 3. So after that as the circuit is symmetrical, so as the current flowing through these three paths are I by 3, I by 3 and I by 3, so here also from this node also the current leaving from the three paths will be I by 3, from here also I by 3, and from here also I by 3. So what's this? It's like I by 6 is coming from here, I by 6 will be coming from this path, so both added up will give you current flowing through this, which is actually I by 3. So if we just break this, we can now apply KVL through this loop. Which loop? The current will be flowing from here, it will go through R, then this resistance, then this resistance, and it will get to the node B. So we can apply the KVL here in this loop. From here it will come here, 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 here. So if we apply the KVL, then what will we get? We will get, actually let me break this part into single part, eliminate this from the picture and then analyze it. So this will look like this: R resistance. After that there will be two more resistances, R, and here we have one more R. Okay, so this is B. Actually this is not needed, this portion we can use this loop. So there are R through this current is flowing, that is I by 3. Let me use red color for it. I by 3, from here it will flow through it, and after this resistance, that is this resistance, through this what current is flowing? I by 6. Why? Because that I by 3 got divided into two parts. Now I by 6 is flowing through this resistance. After that, which current is flowing through this resistance? This resistance, the current flowing through is this. And what is that current? I by 3. Why I by 3? Because this picture is symmetrical. So as the current leaving from this 3 resistance is I by 3, so the current entering into this node will also have I by 3, I by 3, I by 3 equally divided into 3 parts. Okay, so the current flowing through this R resistance, which is this and this, between this resistance, is I by 3, and this node is A. So finally you get one thing, one branch of it. We have eliminated it from the picture and in the sense and taken it to analyze. If we apply the KVL here, what we will find? We will find that R into I by 3 plus, from here, positive drop, negative drop, R into I by 3. After that, R into I by 6, positive drop, negative drop. Across this resistance we will find R into I by 3. Okay, equal to, across this we have applied voltage V, you know that, this voltage, and across it is I is going, is equal to what? Is equal to voltage V is equal to R into I by 3 plus R into I by 6 plus R into I by 3. So this will give this. So from here we can get V by I. Actually what is this? This is the voltage across AB branch, VAB, and we have already said that to get RAB we have to divide this VAB divided by I, which is V by I. VAB in the sense nothing, just voltage across this two nodes A and B. So that is V by I. From here we take I here, so it will give R by 3 plus R by 6 plus R by 3. If we calculate, what is going to be 3, 6, 2 plus 1 plus 2 R. So P by I gives the result 5 by 6 R. So the equivalent resistance RAB is equal to 5 by 6R. Now if in the given picture, if this resistance values are given, suppose the resistance values are given like R is 2 ohm, if these are given as 2 ohm, if it's kind of question, if R is equal to 2 ohm, then V by I will be 5 by 6 into put the value of R multiplied by 2, that will give V by 3 ohm. So this question is asked in many examination, has been asked over the times in many competitive examination. There they give the value of R. In that case you can find out whatever be the value of R. If it's 5, then put 5 here, that will give you 5 into 5 by 6, that will result in 25 by 6. So you can calculate these things like this. Hope you like this. And one thing I will tell you, you can practice this question. Let replace all the resistances by capacitances, then find equivalent capacitance, C equi across AB. Find this and comment down the answer. Thank you.